In 2012, astronomers pointed the Hubble Space Telescope at a tiny patch of seemingly empty sky and discovered something that broke the universe. Not metaphorically, actually broke it. They found a galaxy so massive, so impossibly old, that according to every model, every equation, every carefully constructed theory about how the cosmos works, it simply cannot exist. And yet, there it is, smiling at us from across 13 billion years of spacetime like a cosmic middle finger to physics itself. We named it HFLS3, which is exactly the kind of boring acronym you'd expect from scientists who just found something that rewrites reality. It's like discovering dragons are real and calling one specimen for 7B. But here's where it gets uncomfortable. HFLS3 isn't alone. We've now found dozens of these impossible galaxies. Massive, fully formed spiral cities of stars that existed when the universe was barely 800 million years old, cosmic infants that somehow showed up to preschool with PhDs and mortgages. The universe, it seems, has been lying to us, or we've been lying to ourselves. And the more powerful our telescopes become, the worse the problem gets. Welcome to the crisis at the edge of creation. To understand why these galaxies are cosmological felonies, we need to go back to 1929, when Edwin Hubble, the man, not the telescope, made a discovery that changed everything. He noticed that distant galaxies were moving away from us, all of them, in every direction. And the farther away they were, the faster they were fleeing, like guests who just realized they're at a pyramid scheme presentation. This wasn't because we're universally unpopular. It meant the universe itself was expanding. And if it's expanding now, then if you run the film backward, everything must have been closer together in the past. Much closer, infinitely closer, the Big Bang. From this single observation, we built an entire timeline of cosmic history. The universe began 13.8 billion years ago as an incomprehensibly hot, dense point and has been expanding and cooling ever since. In the first few 100 million years, it was a dark, formless void, just hydrogen, helium, and the faint afterglow of creation. Then slowly, gravity began pulling that gas together. The first stars ignited. Those stars died, forged heavier elements, and their remains became the building blocks for the next generation. Gradually, and this part is crucial, gradually, over hundreds of millions of years, those stars collected into the first galaxies. This is the cosmic recipe we followed for nearly a century. It's elegant, it's mathematical, it works. Except when it doesn't. The James Webb Space Telescope launched on Christmas Day, 2021, with a mirror so large and sensors so sensitive it could theoretically spot a bumblebee on the moon. Its mission, to peer deeper into space and therefore further back in time than any instrument in human history. Scientists expected to see the universe's awkward teenage years, galaxies in the process of assembling, cosmic construction sites, the messy, gradual buildup that our models predicted. What they found instead was a fully operational Death Star when there should have been a pile of lumber. In February 2023, the data started rolling in, and the astrophysics community collectively choked on its coffee. There, in the earliest epochs of the universe, were galaxies that looked like galaxies. Not proto-galaxies, not gas clouds slowly condensing. Actual, mature, spiral-armed, star-churning metropolises. One galaxy, Jade's GSE 130, appeared less than 330 million years after the Big Bang. It contains hundreds of millions of stars and shows clear evidence of multiple generations of stellar evolution. To put that in perspective, if the universe's entire history were compressed into 1 year, this galaxy would have appeared on January 2nd, not slowly forming throughout January, fully assembled on day 2, while the universe was still hung over from New Year's. Another discovery, CEERS 93316, shattered records by appearing even earlier, possibly just 250 million years after the Big Bang. At that point, the universe was still so young that according to our timeline, it should have barely had enough time to produce one generation of stars, let alone organize them into a coherent galactic structure weighing billions of solar masses. It's the cosmic equivalent of finding a smartphone in a Viking burial mound. Now, you might think, okay, our timeline was a bit off. We'll adjust it, but that's like saying the cake finished baking before you put it in the oven. So you'll just adjust your recipe. The issue isn't a small error. It's fundamental. Galaxies don't just appear. They require specific conditions and, crucially, time. First-generation stars need to form from primordial gas, live their lives, explode, scatter heavy elements, and only then can you get the diverse stellar populations we see in these early galaxies. That process has a speed limit, the speed of light, the rate of nuclear fusion, the lifetime of massive stars. You can't skip steps, you can't fast-forward physics. And yet, these galaxies did exactly that. Even more disturbing, they're not small. HFLS3 is producing stars at a rate 2,900 times faster than the Milky Way currently does. At an age when it should barely exist, it's operating like a factory at 2,900% capacity. Where did it get the gas? How did it concentrate that much matter that quickly when the universe was still relatively smooth and uniform? How did it avoid tearing itself apart? Dr. Ivo Lab, one of the astronomers studying these objects, put it diplomatically, if the masses are right, then we are in uncharted territory. Translation, we have no idea what's going on, and everything might be wrong. Some scientists proposed that maybe we're mismeasuring the distances. Maybe these galaxies aren't as far and therefore as young as they appear. But follow-up observations with spectroscopy, the gold standard for cosmic measurements, confirmed it. They really are that old. They really are that massive. They really shouldn't be there. When faced with the impossible, scientists do what they do best: propose theories, test them, and watch them fail spectacularly. Theory 1, maybe dark matter behaved differently in the early universe, clustering more efficiently and pulling gas together faster than we thought possible. Problem, we have no evidence for this, and it would contradict everything we know about dark matter's behavior throughout the rest of cosmic history. It's essentially saying, what if the rules were different back then? Which is less a theory and more a cosmic shrug. Theory 2, perhaps supermassive black holes at the centers of these galaxies turbocharged star formation through feedback mechanisms we do and understand. Problem, those black holes would themselves need to have formed impossibly early and grown impossibly fast. You're solving one impossible thing by invoking another impossible thing. It's turtles all the way down. Theory 3, population 3 stars, the hypothetical first stars, made purely of hydrogen and helium, were far more massive and short-lived than we assumed, seeding galaxies faster. Problem, even if true, the timescale is still too short. You need multiple generations of these stellar behemoths living, dying, and recycling in just 200 to 300 million years. That's a cosmic assembly line running at speeds that would make Henry Ford jealous. Theory 4, we're completely wrong about something fundamental. This is the theory nobody wants to say out loud, but everybody's thinking. What if our understanding of the Big Bang's aftermath is incomplete? What if the universe's expansion rate was different than we calculated? What if the Landis-CDM model, the standard model of cosmology, has a fatal flaw we haven't found yet? It wouldn't be the first time. We've already had to invent dark matter and dark energy to make our observations fit our theories. And we still don't know what either of them actually are. They're placeholder names for something is clearly here, but we have no idea what. Now we might need a third placeholder. Dark embarrassment. The James Webb Space Telescope continues to find more of these cosmic rule breakers. The Atacama Large Millimeter Array in Chile confirms them. Every new observation is supposed to clarify the picture, but instead, it's like someone keeps adding puzzle pieces that don't fit the image on the box. In July 2023, astronomers announced the discovery of ZFUDS 7329, a galaxy that appears to contain stars that are older than the universe itself. Which is a sentence that shouldn't be possible to write in a non-fiction context. Let that sink in. We found stars with an estimated age of 13.8 billion years in a galaxy that formed 13.1 billion years ago. Either our dating methods are catastrophically wrong, or time is more flexible than we thought, or reality is gaslighting us. Meanwhile, simulations attempting to recreate the early universe keep failing to produce what we're seeing. Supercomputers running for weeks can't replicate these massive early galaxies without making assumptions that break other parts of the model. It's like trying to balance your checkbook and discovering you somehow spent more money than exists in your account, your wallet, and the entire banking system combined. Some researchers are now quietly suggesting that we might need to completely revise our understanding of the first billion years of cosmic history. Others are less quiet about it. Dr. Stacy McGaugh, an astronomer at Case Western Reserve, has been pointing out for years that galaxy formation doesn't behave the way our models predict. And these latest discoveries are, in his words, just another brick in the wall of problems. A wall that's looking suspiciously like it might be load-bearing. So what have we learned? First, the universe is under no obligation to make sense to us. Our models are human constructs, elegant, mathematical, and beautiful, but ultimately, tools we've built to approximate reality. When reality doesn't fit, the tools need updating, not the other way around. Second, the more we look, the stranger it gets. Every leap in observational technology from Galileo's telescope to Hubble to Webb hasn't simplified the cosmos. It's revealed deeper layers of complexity. The universe is a mystery that grows more mysterious the more we investigate it. Third, we might be living through a paradigm shift in cosmology. Future textbooks may mark this era as the moment when our understanding of galaxy formation fundamentally changed. Or they might mark it as the era when we finally admitted we were missing something big. Here's the uncomfortable question we're left with: if galaxies that shouldn't exist do exist, what else have we gotten wrong? How many other cosmic ghosts are hiding in our blind spots, waiting for the next generation of telescopes to reveal them? How many of the certainties we teach in classrooms are actually just our best guesses, destined to be overturned by better data? The universe has been around for 13.8 billion years. Humans have been seriously studying it for maybe 400. That's 0.00003% of cosmic history. We're infants trying to understand the lives of our great-grandparents by examining a single photograph. If you found this unsettling, good, hit subscribe and stick around, because the deeper we look into space, the weirder it's going to get. These galaxies might be impossible, but they're real, and that means somewhere in the gap between impossible and real is a truth we haven't discovered yet. The universe is trying to tell us something, we just haven't learned to speak the language. And that should terrify and excite you in equal measure. The stars are older than they should be. The galaxies exist before their time. And we're standing in the dark, holding a flashlight that keeps revealing things that shouldn't be there. Sleep tight.